Alright, so in this video we're going to use calculus to derive the equation for gravitational potential energy. To start off, let's remind ourselves the definition of potential energy. Potential energy equals negative integral from infinity to r of force dr. And through Newton's law of gravitation, we also know that the force exerted by gravity is force equals negative g times the mass of object 1 times the mass of object 2 all over r squared. Remember that big G is the gravitational constant, which is always equal to about 6.67 times 10 to the negative 11. And in this case, r is the distance between the center of mass of object 1 and the center of mass of object 2. So let's substitute this force into our equation for potential energy. Using a bit of calculus, we can use this to derive a simpler equation for gravitational potential energy. Let's start by moving our coefficients out of the integral. Notice how when you take out the negative big G times big M times little m, the negative in front of the integral cancels out. So don't mess up your signs. Now let's rewrite this as and using power rule, we know that and let's rearrange this to and now we'll plug in our bounds to subtract. Now, what do we do about the infinity? Well, we know that the limit as x approaches infinity of 1 over x equals 0, because as the number on the denominator grows at a faster rate than the numerator, the value of the fraction becomes smaller and smaller until it reaches 0. Therefore, and now we have our equation for gravitational potential energy. The gravitational potential energy equals negative g times the mass of object 1 times the mass of object 2 all over r. Now let's work a problem using this formula for gravitational potential energy. Let's say there's a puppy out in space. And it weighs about 50,000 kilograms. And a circular orbit around the puppy is a 3,000 kilogram tennis ball. The distance between the center of mass of the puppy and the ball is 8 times 10 to the 7 meters. So, what would be the total energy of this system? Well, we know that the total energy is equal to the kinetic energy plus potential energy. So, total energy is 1/2 mv squared plus a negative g big M times little m all over r. We have everything we need to solve except for the velocity. However, to keep an object in circular orbit, the mass times centripetal acceleration must equal to the force of gravity. So simplifying this, we get now, let's plug this back into our energy equation. Energy equals 1/2 m gm over r minus g times big M times little m all over r. Which conveniently works out to energy equals negative 1/2 g times big M times little m all over r. And plugging in the given values, we get energy is equal to about negative 6.25 times 10 to the negative 11 joules.